Okay, this is chapter 12, lesson 4, and today we're looking at 3D vectors. We're going to do some geometric problem solving. Now this is only the first part of geometric problem solving. There's actually a much more difficult part coming next, which will be in lesson 5, but you have to know some of the skills that are involved in this stuff to be able to do the harder parts of geometric problem solving. So let's get cracking. So the points A, B, C and D are these things respectively. Give the vectors A, B and C, D as column vectors. What type of quadrilateral is A, B, C and D? So the first part of it is give the vectors A, B and C, D. So A, B will equal the parts of B take away the parts of A. So this is going to be 4, 7 and -1. Take away each of 2, 3 and 4, which will come out as 2, 4 and -5. Okay, that's AB. And then C to D is going to be the parts of D take away the parts of C. So we're going to have 2, 5 and -5. Take away -2, -3 and 5, which is going to be 4, 8, so those two negatives will make a positive obviously, and -10. Okay, so the vector AB will look something like that, and the vector CD will look something like that. They're going to be parallel to each other. You can see that they're parallel because you've got 2, 4 and 5, and if you double each of those numbers you get 4, 8 and -10. You could, if you wanted to, factor it out, and so you could write this as 2, lots of 2, 4 and -5, and you could even go so far as to say that 2 of, this is AB, of the vector AB is equal to the vector CD. Okay, they are parallel to each other. They're disconnected as well. With shapes, when you've got these coordinates A, B, C and D, they will be in order either clockwise, A, B, C and D, or they will be anti-clockwise, so you'd have A, B, C and D. But A and C would always be opposite to each other diagonally, and B and D would always be opposite to each other diagonally in a quadrilateral. So they'll always go clockwise or anti-clockwise. And so A and B and C, AB, which is that way, sorry, and CD, which is this way, they are parallel to each other. Okay, so what we know is that since this is, you need 2 lots of AB to get to CD, we've got a longer length, and so you actually have a trapezium. Okay, moving on. Next, the points A, B and C are these things. Give the point D so that ABCD is a parallelogram. Now the first thing to do really would be to try, if you can, to get some sort of sketch of it. Now for me, I always tend to just do my sketch based off of the X and the Y parts of these coordinates. Now obviously the Z part's still involved, but to get a visual idea of what's going to happen with it is pretty important, and so it's useful to get these sketches in. So we're going to have 1, 2, which is going to be A there, so that's going to be A, which is equal to 1, 2 and 3. B will be further along and further up, okay, up like that there. Okay, so that will be B, which is equal to 4, 5 and 8. C will be a bit further along and a bit further up, like that. That will be C there. Okay, C is equal to 5, 6 and 9. And so we're going to have some other position D there, such that this line must be parallel to this line, okay, and this line here must be parallel to this line here. Okay, there could be another D which could go over that way there, okay, which would be over there, and so you'd have kind of this bit, they would be parallel to each other, but you'd also have these other kind of really long diagonals. Okay, they would be parallel to they'd be parallel to each other, but obviously that would require A and C to be linked together, which they don't. Okay, we said that in the previous slide. So you might be thinking, well, I could have this really long diagonal here, but if that's called A and that's called B, then this would be called, if that's called A, pardon me, and that's called B, then this would be called C and this would be called D. Okay, so that would be A, there'd be D, B and C, and so you'd be expecting A and C to join up, which they can't because of the way that these letters are arranged. Okay, so you might be thinking there's another position where you could get a parallelogram. It doesn't happen in this case. Okay, so we've got ABC and we need to find out D. Now to get to it, we could find that the position A plus the vector B to C would give us D. Okay, if we're at A and we travel along this exact same vector, we will end up at D. So we could say, well, A, which is equal to 1, 2, 3, plus B to C, which was 5, 6, 9, subtract, 4, 5, 8, which is going to equal 1, 2, 3, plus 1, 1, 1, which is going to be 2, 3, 4. Okay, and this will be 2, 3, and 4 for point D. All right, so not too bad, nothing too scary really. Just watch out for the kind of, you might be thinking that there's two positions for the parallelogram, but of course there's only one in this case because of the way the letters are arranged. All right, moving on. Now this question here looks absolutely brutal, and it's really, really, really easy, but extremely important. If you don't understand this, it will make the next lesson really very, very, very difficult. And the next lesson is, in my opinion, one of the harder parts of the 3D vectors, and one of the more interesting parts certainly, but you need to know how to do this. Now, given that this vector, which it is, okay, if P, Q and R are just values, then you've got 3i plus something j plus something k. That is just a vector. And if that vector is identical to this other vector, then 3 must equal r, p plus 3 must equal 5, and pqr must equal negative 24. Okay, so the first thing I'm going to do is I'm going to say, well, 3 equals r. I'm going to say that p plus 3 equals 5. And I'm going to say that pqr is equal to negative 24. Okay. Well, r equals 3 is already found. That's already useful. Okay. P equals 2. Okay, that should be obvious as well. And if r equals 3 and p equals 2, then we need to find out q, which is going to be 2 times 3 times q is going to equal negative 24, which is 6q equals negative 24, which means that q is equal to negative 4. Okay, there are p, q and r visible for you. Now that is really easy, looks difficult, but it's very, very simple, but extremely important, really, really, really important. All right, the most important things that you can take from this lesson were that you need to know that when you've got A, B, C and D, that will be either the clockwise or the counterclockwise order of the vertices. That's really, really important. You should still be remembering how to do, say the vector CD is the point D, take away the point C. That's really, really important. Okay, all of this stuff was fairly straightforward, and this was very, very easy but extremely important. Your tasks for today are in the Edexcel Year 2 Pure Book, page 347, exercise 12C, questions 1, 2, 3 and 4, and if you want a bit of an extension, do 5 and 6. Get in touch if you're struggling. Make sure that you've taken a picture of it and you popped it on your Google Classroom. Make sure you mark it before you put it on there. Good luck.